So here's our two equations that we finished with in the previous video. We had set the window, the viewing window, up for this function. So I'm going to go back to that. I'm going to continue to use that function for now. So let's go to the graph. Now, this graph peaks out, as we said before. It peaks out over here. It goes up the one side and comes back down the other, which means in between it tops out or peaks out or hits a highest point. Would be nice if we could find out what the coordinates of that point are. Now, keep something in mind. The calculator is using pixels. So even the color calculators, which have a much finer resolution, it's still pixelated and it's still not exact. That's one thing to keep in mind. Here's another really important thing. As much as this peak may look like it lines up with this tick mark, and maybe it does, maybe it doesn't, we don't know for sure. Remember, that's not 3. In the previous video, we changed the scale. This is 5, 10, 15. So it can be very, very misleading to try and eyeball this one. We don't need to do that. It's a calculator. It can probably do better than that. Now, some of you, if you have any experience with the calculator, or even if you don't and maybe just notice this, you might have seen a trace button here. Don't ever, ever, ever use that. It's awful. Well, how can it be awful if it traces? I mean, it sounds like it would trace the graph, right? Well, you really want to know why it's awful, you got to try it out. This is the only time you should ever, ever use the trace button. Oh, look at that. It puts a cursor on the function, on the graph, and hey, it even tells you the coordinates. What's so bad about that, right? Well, let's start moving towards that peak up there. Now, you use the left and right arrows to move the cursor along. So we want to go to the left. Oh boy, look at these numbers down here. That's pretty disgusting. Oh, this is just awful. Not a whole number to be seen, not even a nice decimal. These values are disgusting. In fact, if you look at where the cursor is, we went right past the extremum up there, right past that peak, and we never once saw a friendly value. Now, it's possible that the peak up there happens at a really disgusting value, but I'd say it's probably more likely that the calculator didn't find the exact point because it's tracing the pixels of the graph. And the pixels are at certain locations. And those locations are not very nice. So you're never going to want to use the trace button. Ever. Never, ever, ever use the trace button. Instead, look right above the trace button where it says Calc. That Calculate menu has the things that we need to find information from the graph. Remember, it's in blue, so we're going to have to press the second button. There are several things that the calculator can determine from the graph of a function. Some of them are fairly obvious. Some of them, like these last two, are calculus things, so you have no idea what you're looking at with them, and that's okay. You won't need them. But I think the most obvious ones here are perhaps the minimum and maximum. The calculator does distinguish between the two because of the nature of the way it's programmed. Any of you guys who have any background in programming, in taking any kind of computer programming courses, might have an understanding of why they would need to be done separately. It's a similar algorithm, but they are looking for different things, so the calculator needs a distinction. In this case, we're looking for a peak, a maximum, so we're going to choose that. Now it takes us back to the graph, and it puts the cursor, well, again, at one of those disgusting points, but that's okay. It doesn't matter that it gave us a disgusting point. What does matter is that we give the calculator the information it needs to find the maximum. To do that, the calculator needs to be limited to a certain range of x values. That's why it says left bound. It wants to know what's the left boundary. It needs, as I said, a range of x values, an interval of x values. So we need to tell it what the leftmost, or the lowest or leftmost x value would be. And it can be anything. It just has to be somewhere on the left side of this. So I'm just going to leave it where it is and hit enter to select it. Now, the older calculators just put an arrow, but the newer ones actually put this dashed line, which is kind of cool. It'll be more clear why that's cool in a moment when we give it the next thing it's asking for, the right bound. As with any interval, if you give it a left number, it's got to have a right number. So in this case, we're going to move the cursor past that peak somewhere to the right of it. Doesn't have to be perfect, could be anywhere. And I'm going to hit enter again to set the right boundary. Kind of the cool thing here is that we now have a defined section of the graph in between those two dashed lines. And the idea is that the calculator will now only look in between them to find the maximum. So in that way, we've kind of isolated it a little bit and said, only look here. Now, the third thing it's going to ask for is a guess. The guess is really not important if you set your left and right bounds properly. The guess is, well, let's say there were two different maxima in the interval you set. The guess is to kind of point the calculator towards one or another. If you set your left and right bound to only isolate a single maximum, then the guess really is unimportant. You could put the guess anywhere in between. It doesn't even need to be near the extremum. As long as it is some point in between the left bound and the right bound. And you hit enter. And there's the maximum. It finds it for you. Now, again, these are not particularly nice values. The x value is, the decimal portion of it should be somewhat recognizable. That's -1 and 2/3, or -5/3. The y value, not so much, but, what you gonna do? But there you go, the calculator found it exactly for us. For a little practice, we're going to run through that again to find this extremum down here, this minimum. So again, we could use the trace function, but it's not going to get us there. But we can use the calculate menu up above it. This time we're going to want the minimum. So again, it's going to ask for the same information, the left bound, anywhere to the left of it, doesn't really matter, and the right bound, somewhere to the right of it, doesn't really matter, and then a guess anywhere in between it, doesn't really matter. And there's the minimum. Wait, what is this? Is that another disgusting value? Well, that unfortunately does happen sometimes. I'm not going to give you a full computer science lesson on it, but occasionally the calculator or computer will sometimes be off by the tiniest little amount. 2.9999999. And I think it would be safe to assume it would keep going with a whole bunch of nines. That's 3. It's so unbelievably close to 3, you can call it 3. If it was 2.96532, oh, that's not quite close enough. 2.96 is not quite close enough. I mean, it's got to be really, really unimaginably close. for us to be able to say, okay, it rounds up. Now, some of you guys, depending on where you set your left bound and right bound, some of you might have gotten 3.00000001. So your answer is just a tiny bit off in the other direction. It's a little bit too big. But again, it's the tiniest little amount too big. You're going to have to pay attention and recognize when that occurs, that if it's unbelievably close to a nice recognizable value, it's probably the nice recognizable value. But in a nutshell, that's all you have to do to find Extrema. Graph the calculator, or the function on the calculator, adjust the window. You need to be able to see the Extrema you're looking for. They need to be visible on the screen. And then you go into the calc menu here above the trace button. And you choose maximum or minimum depending on what it is you're looking for. Fairly straightforward. The advantage here, of course, is that since you've got this video, you can come back and rewatch it at any time to refresh your memory on the procedure. So there you go.